This is problem number 4 from section 9.6. In this problem, they say find M inverse, and they give us M equals this 3 by 3 matrix E. And what they want us to do is they just want us to find the inverse of this. So just like we did in the previous problem, we want to take the identity matrix, except for this time we're going to use a 3 by 3. And we want to essentially take this matrix E and set it equal to this matrix. So all I'm going to do is I'm going to write 1, 0, 0, 0, 1, 0, and 0, 0, 1 right next to this. And I'm going to pretend that this middle, that middle bracket is actually just that line where we kind of set it equal. So now we're going to use Gauss-Jordan elimination to do this. So Gauss-Jordan to find the inverse. All right, here we go. Let's try to be efficient in this problem too. So I'm going to multiply the top by -3 times row 1. And when we do -3 times row 1, we're going to get -3, -3, 0, -3, 0, 0. We still have 3, 1, 1, 0, 1, 0, 0, 1, -1, 0, 0, 1. Now we're going to take we're going to do row 1 plus row 2, and that's going to equal row 2. So I'm going to get, in the middle, I'd get 0, -2, 1, all right, when you add those, -3, 1, 0. We do the 0 and the 0. On top, I'm going to go ahead and, I did -3 times R1 here. I'm going to go ahead and, just to save some space, I'm going to do -1/3 R1 as well. So this just takes this back to what it was originally, which is 1, 1, 0, 1, 0, 0. So I said I was going to do it most efficient. This is one piece. This is the other piece that we did. We obviously did this one first, then this second. We get 0, 1, -1, 0, 0, 1. All right, I want to cancel both this 0 and this 0 if I can at the same time. So I'm going to multiply the top row by 2, and I'm going to multiply the bottom row by 2 as well. R3. So that's going to give me 2, 2, 0, 2, 0, 0. This will be still 0, -2, 1, -3, 1, 0. This is 0, 2, -2, 0, 0, 2. And then I'm going to take row 2 plus row 1. That's going to equal row 1. And then I'm going to do row 3, row 2 plus row 3, and that's going to equal row 3. So I'm going to start by taking row 2, add it to the top. That's going to give you 2, 0, 1, -1, because -3 and 2. 1 and 0 is 1, 0 and 0 is 0. And then I'm going to do 0, let's see, I get 0 down here, 0 here. This will give you -1. This is -3, 1, 2. And I still have 0, -2, 1, -3, 1, and 0. All right, I need to cancel this row and this row. And I actually can do this at the same time because this is already -1, so I need to cancel these both to 0. So I'm going to do that at the same time. I'm going to say row 3 plus row 1 equals row 1. And then I'm also going to do row 3 plus row 2 equals row 2. So we're going to start by taking the bottom, adding it to the top. That'd be 2, 0, 0, -4, 2, when you get the 1 and the 1, and then 2. Now I'm going to take it and do the middle row. So it's 0, -2 when you add these two together. -1 and 1 is 0. -3 and -3 is -6. That's 2. And that's 2. And then we're left here with still 0, 0, -1, -3, 1, and 2. We're real close. So we have one last step to do. I'm going to slide up just a hair. Last step, we're going to do 1/2, row 1. We're going to do -1/2, row 2. And we're going to do -1, row 3. Do them all at the same time. So we're going to get 1, 0, 0, -2, 1, 1. For the top row, then we're going to get 0, 1, 0, 3, -1, -1. And then -1 times those just changes those signs. So 0, 0, 1, 3, -1, -2. So the inverse we have is -2, 1, 1, 3, -1, -1, and 3, -1, -2. I'm just going to kind of point at it. Is the inverse of M. And that's how you find the inverse. Use Gauss-Jordan elimination to do that.